In this video, we are going to cover 2.4 Born-Haber Cycle. At the end of this topic, students should be able to define lattice energy and electron affinity. Second, explain the following effects on the magnitude of lattice energy, ionic charges, and ionic radii. Third, sketch Born-Haber cycle for simple ionic solids using energy cycle diagram and energy level diagram. And fourth, calculate enthalpy changes using Born-Haber cycle. Lattice energy is defined as the heat change when 1 mole of solid is formed from its constituent gaseous ions. It means that the product is 1 mole of solid compound and the reactant is gaseous ions. Lattice energy changes are large and the values are negative because energy is needed to break apart the lattice. See the example below. We have reactants in gaseous ions, which are Na plus and Cl minus, while the product is a solid compound, which is NaCl solid. The lattice energy becomes more negative as the ionic charges increase and the ionic radii decrease. There is a stronger attraction between small, highly charged ions, so the delta H is more negative. For example, between MgO and Na2O, since Mg2 plus has a bigger charge than Na plus, and the size of Mg2 plus is smaller than Na plus, hence the delta H is more negative, which means the lattice energy of MgO is bigger than Na2O. Electron affinity is defined as the heat change when 1 mole of gaseous atoms gains 1 mole of electrons to form 1 mole of gaseous ions. This means that the reactant is 1 mole of atom in gas phase plus 1 mole of electron produce 1 mole of ions in gaseous state. For example, we have the equation below for the first electron affinity of oxygen. 1 mole of oxygen in gaseous state plus 1 mole of electron produce 1 mole of O- ions in gaseous states. Now we look at Born-Haber cycle. It is the process of ionic bond formation that can be broken down into stages. At each stage, the enthalpy changes are considered. The Born-Haber cycle is often used to calculate the lattice energy of an ionic compound. It is useful for predicting the stability or existence of ionic compounds. The stages of Born-Haber cycle can be simplified into an acronym file F, A, I, E, and L. F stands for enthalpy of formation, where the product must be 1 mole. A refers to the enthalpy of atomization, where the product must be 1 mole in gas phase. I is ionization energy, E is electron affinity and L is lattice energy. The lattice energy means that the product must be 1 mole of solid compounds and the reactants are gaseous ions. For example, by using the following information, construct a Born-Haber cycle and energy level diagram. Then, calculate what is the lattice energy of NaCl. Remember the acronym before? The first equation we must write is the enthalpy of formation. For NaCl, the equation is Na solid plus 1/2 Cl2 gas produce NaCl. In this equation, we must make sure the number of mole of product is 1 mole. So this is the enthalpy of formation. The second one is atomization. The atomizations means that we want to produce 1 mole of gaseous product. In this equation, Na solid must be converted into Na gas. So this is the enthalpy of atomization of Na, while Cl2 gas is converted from Cl2 molecule into Cl atom in gas. So this is the enthalpy of atomization of Cl. Then the acronym I means ionization energy. This applies to Na. Na will ionize into Na plus, and this is called ionization energy. While Cl will gain electron and become Cl minus in gas. This is called electron affinity. And lastly, we want to write the equation for lattice energy. Lattice energy means that the product is 1 mole of solid compound, which is NaCl, and the reactants are Na plus gas plus Cl minus gas. This is lattice energy. That's how you construct an energy cycle diagram. How about energy level diagram? First of all, from the data given, we must know whether the delta H given is positive or negative. Here we can see that for formation, electron affinity and lattice energy, it is negative, while for atomization and ionization energy, it is positive. In this example, even though the lattice energy is not given, we must know that lattice energy is always negative delta H. So from here we know that for every negative value, the arrow must be written downwards, while for every positive value, the arrow is written upwards. The first equation we want to insert into this energy level diagram is enthalpy of formation. We write the reactants at the same level of energy equal to 0 and pointing downwards to produce the product NaCl since the value is negative. This is F, enthalpy of formation. Next, we write an arrow pointing upwards to convert Na solid into Na gas. This is the enthalpy of atomization of Na. Next, another arrow pointing upwards to convert Cl2 molecule into Cl gas. This is the enthalpy of atomization of Cl. Next is I, ionization energy. We write an arrow pointing upwards to show the ionization from Na to Na+. Then, from that equation, we draw an arrow pointing downwards to represent the electron affinity of Cl, E. And lastly, the letter L means lattice energy, which is from Na plus gas plus Cl minus gas produce NaCl solid. So, we write an arrow from the Na plus and Cl minus to the NaCl at the bottom. If we apply Hess law here, we can see that the delta H1 is equal to delta H2 plus delta H3 plus delta H4 plus delta H5 plus delta H6. So, by using the value of delta H given, we can find the value of lattice energy. And the answer for this calculation is -777 kilojoule. That's all for this video. Thank you.